Alright class, today we're doing solving trig equations. Notice how it says to solve over the interval from 0 to 2 pi. So that means that when we inverse, we're going to have more than one answer this time. So let's take a look in how we do that. We're really solving for the trig function, so you're trying to solve for this. So if I'm trying to solve for cosine of theta, I have to divide by 2. So I get cosine of theta is equal to 1/2. Well, now to find theta, this is just doing the inverse. So theta equals cosine inverse of 1/2. And here's where your unit circle knowledge has to come into play. Cosine is positive in quadrant 1. It's 1/2 when you are at pi over 3. Okay? Now you have to find the other spot where it is. So cosine is positive here, and it's positive here. So I'm in quadrant 4 now also. Now here's where it's different. I do not want you to tell me negative pi over 3. I want you to tell me 0 to 2 pi. So there's two ways to go about that. You know that if you go halfway around the circle, since we're in pi over 3 intervals, this is 3/3, and then if I get back around, this is 6/3. So a full circle will be 6 pi over 3. But I want one less than that because of this angle here. So the other answer should be 5 pi over 3. So my answers to the problem are pi over 3 and 5 pi over 3. Because both those angles will give you a cosine of 1/2. Okay, let's do the same thing for sine. So if I move that over, I get -1, which means that I get sine theta equals -1/2. Well, since pi over 3 was the reference for cosine being 1/2, pi over 6 is a reference for sine. However, it's in quadrant 4 with a pi over 6 reference. And then the other place sine is negative, the y, all students take calculus, so it's down here. So I need these two. Remember, it's a pi over 6 reference. So if I go halfway around the circle, that's 6 over 6, and then this is 12 over 6. So I look at this spot. This spot is one more than this one. So I get theta is equal to 7 pi over 6. This one is one less than 12, so I get 11 pi over 6. And those are my two answers. Alright, halfway done. Let's do two more. Cotangent's a little trickier, but that's just because you need to know your cotangent. If I solve this, I get √3 cotangent of theta equals 1. So I want to know where cotangent of theta equals 1 over √3. Now, if you're not good about cotangent, you can say, or I want to know where tangent of theta equals √3. Either way you want to look at that, it's the same thing when you're doing this thing. So tangent is √3, either 30 or 60, and actually it's the bigger one is when it's at 60. So we're back at a pi over 3 reference, and actually that's one of our answers because tangent's positive there. The other place tangent's positive, all students take, is down here with the same reference angle. So I have these two right here. So to get this one, this is 3 over 3. If I go one more, it's 4 pi over 3. So I have two angles. I have pi over 3 as the reference, and then in quadrant 1, and then I go all the way to quadrant 3, and it's 4 pi over 3 is the one with the reference there. Okay, last one. This is a little trickier, but not by much. There's just, so we're solving this. However, we have this inside shift, you can think of it as, around the unit circle. But we don't have to deal with that yet. I'm going to rewrite this as tangent, and I'm going to call all of this just x. So I'm going to define where tangent is equal to 1. So I use my unit circle, and tangent is 1 at the 45, or pi over 4. And we just talked about this. Where's the other place tangent is positive? It's over in quadrant 3. Since this is 4/4, this is 8/4, because we're in fourths, this other one is 5 pi over 4. So I get x is equal to pi over 4 and 5 pi over 4. Now, however, that's not my final answer though, because we made x be this. So now we can do, once we have the shift, the angles, we can do the shifts. So I get theta minus pi over 2 is equal to pi over 4, and I get theta minus pi over 2 is equal to 5 pi over 4. So basically we're going to add 1/2 pi to these. Well, to add 1/2, that's 2/4. So we end up with theta is equal to 3 pi over 4, and theta is equal to 7 pi over 4. And those answers are still both within 2 pi. So all we had to do on that one was do a shift after the fact. Okay. So I know your test is non-calculator, but you can do this with the calculator too. I'm going to just show you one, just to show you how to do this. When you do this, you want to use inverse tangent. So if you inverse tangent 2.4, you end up with, I think it was 67.4. I don't actually have my calculator with me. But let's just say it's 67.4. I think that is right, actually. So anyway, if it's 67.4, that is in quadrant 1 right here, with a reference of 67.4. Now let's pretend that we need to do what we did up there. We need to find the other quadrant where tangent's positive with the same reference. Well, again, tangent is positive in quadrant 3, and this is a 67.4. So to get the final answer, you would have to go from here all the way to here, and that would be adding 180 to 67.4. So when you add those together, you get 247.4 degrees. So the two answers for this problem would be 67.4 and 247.4. But the process was the same. You just had to use your calculator to get that first angle, and then you have to find the other quadrant like we did for the other ones up above, and then you answer that too. Okay, so that is solving trig equations day 1. We're going to do day 2 soon. That'll involve some factoring. So we'll see you then.